goes in twice. There's one left over in the tens. So now we bring down the 8. We have 18 ones. It goes in one time for 21 as how many whole groups come out, but there's going to be a remainder. The remainder is 6, and you needed 12 to make a whole. So that's 6/12, which is the same thing as 1/2. So you can look at it like there's 6 out of what you need's 12 left, or you could simplify that. 6 over 12 is the same thing as 1/2. So it's 21 and 1/2. And that answer is D. So that answer is D. Let's go to 35. 505 divided by 5/10. So the decimal is in the divisor. You cannot have a decimal in the divisor because we're counting groups of 5/10, and that's really hard to do. So instead, we can make that a whole number by multiplying it by 10. You move that decimal over once, you just have to do the same thing in here, which there's an invisible decimal after the 5. So it turns it into 5,550 divided by 5. They both have the same answer. This one we're counting by 5s instead of 5/10. How many 5s go into 5? 1. What's left over? Nothing. You used it all. Bring down the hundreds. How many 5s go into nothing? Well, none. You cannot do that. So you put a 0. There's nothing that goes in. Now, you bring down the 5. How many 5s go into 5? 1. Perfect. There's nothing left over. Everything came out. And now you're left with this guy right here. Whether you bring it down or not, you know 5 can't go into it. So you're left with the answer of 1,010. And 1,010 is B. 1,000. So 35 is B. Let's go to 36. 51 and 5/10 divided by 5. 51 and 5/10 divided by 5. So 5 goes into 5 one time. There's the decimal's on the inside, so that's okay. You're allowed to work with the decimal on the inside. So the only thing you have to do is make sure that all the place values line up. Make sure your decimal continues to be in that location. 5 goes into 5 one time. There's nothing left over because it went in perfect. Bring down the 1. 5 cannot go into 1. So you say there's no groups that come out of it. The decimal we already put up. So now you bring down the tenths, and 5 goes into 15 3 times. So that answer is 10 and 3/10, which is B. 36 is B. Let's go to 37. Would have been helpful if I would have printed this off, but I didn't. All right, 37. We have word problem. And this is a word problem with the famous typo. I'm always good for at least one typo. Ryan went shopping and he purchased 2 shirts. Each of the shirts were $16. He also bought a pair of sneakers. The sneakers cost 2.5 times as much as the shirt. How much did he spend on the shirt? So the idea here is they told us the 2 shirts were $16. With that information, you know, he spent $8 on the shirt. Oh, no, I'm sorry. Each shirt was $16, so he spent $32 total on shirts. But that's not what the real question was. The real question was supposed to ask how much he spent on his sneakers. Now, so if you answered 32, you're correct on this question. Or you could change it to sneakers. If you change it to sneakers, we want to find out what 2.5 times 16 is, because it was 2.5 times as much as one shirt. We know one shirt was $16. So if we find 2.5 times 16, then that will tell us how much each sneaker was. So the answer here is 32, but if you wanted to find sneaker, which it's not asking about sneaker, but I'm asking you right now about sneaker, you do 2.5 times 16. So 2.5 times 16. We have a mixed number there. We want to turn that into an improper fraction before we can multiply or divide with fractions. So 2 times 2 plus 1. So the 2 wholes is 4 halves. And you have a half. So that's 5 halves. Times, and 16 can turn into a fraction very easily. You could reduce those first. That would turn into an 8. That would turn into a 1. But if you're not comfortable with reducing, multiply across. You get 80 halves, which is 40. So that answer would be 40 if anyone was asking you about sneakers. Let's go to 38. 38. Question is, an orange grove in Florida has 865 amber sweet trees and 32 rows of 40 sunstar trees. How many more sunstar trees than amber sweet trees does the orchard have? So, how many more is subtraction? So we are going to take, we're going to take 865, and we're going to subtract from it 32 times 40. So 32 times 4 is 128. So 32, you could go like this, times 40. You ignore the 0. 4 times 2 is 8. We have 12, and then you just want to add the 0. So I wrote that incorrectly. Since there are more of these trees than those trees, order matters in subtraction. We should write, you should have written 32 times 40 minus 865. So you get your answer here, which is 1,280. You get rid of that. So you have 1,280, and we have the amber sweet trees. We have 865. So you have 0 and lose 5. You cannot do that. You have 10 and lose 5. There's 5 left. You have 7 and lose 6. 1. And then you have 12 hundreds and you're losing 8 hundreds. So that answers 400. So that answers 415, which is B. So 38 is B. Let's go to 39, shall we? 39. All right, so we have this beautiful looking coordinate plane, right? And it's not going to pick it up. Oh, there we go. That works. We have that coordinate plane right there. It's going to ask us which one is 6, 0. Well, 6, 0 would mean go over 6, up none, and that would be D. And then number 40 is saying what is 4, 2. So technically we were told not to teach anything that we did not teach thus far, but we kind of just started with this unit, so I'm going to let it slide. So when you are plotting something on a coordinate grid, the first number you see is called the x coordinate, which the x-axis is horizontal, so it's going sideways. So if something is telling you 6, 0, that's saying if you start at the point of origin, which is the corner, which is 0, 0 technically, if it's 6, 0, you go over 6, up none, and you see D staring at you right there. And then which coordinate's plotted at 4, 2, same idea. The first number is always over, 4 over, 2 up, and then if you go 4 over or 2 up, A is like sitting there saying, hey, I'm here. So number 40 is A. 41. What are the coordinates, or what are coordinated for C? What are the coordinates? So that's another wonderful typo. What are the coordinates for C? So if you look at C, it is staring there. It's staring at you right by the 4. So the first question before you want to jump into the 4, how many spaces do you go over before you shoot forward? You don't move to the right at all. So the x-axis is 0, or the x-coordinate is 0. And then the x-axis is go up 4. So it's 0, 4. So that answers A. 41's A. 42. What are the coordinates for B? What are the coordinated for B? Yeah. So the coordinates for B, same thing. Look at the map. It's staring at you right there on top of the 5. So the first thing that you would do, and I always tell students, think about like Battleship, or think about the crane game when you go to the restaurants and you beg your parents for a couple dollars to play the crane game. You have to go, you can move it one way, one direction, and then as soon as you're done with that, you got to move it the other direction. So B would be 5 over, 4 up. So that would be 5, 4, which is A. 43. Which expression represents multiplying the difference of 12 and 3 by 4? So, order of operations. Parentheses, please. Excuse is an exponent, which we don't deal with in 5th grade. My dear is multiplication or division, whichever one comes first from left to right. And then Aunt Sally, which is addition and subtraction from left to right. So please excuse my dear Aunt Sally. The difference of 12 and 3 by 4, we're going to multiply that by 4. So if you just put 12 minus 3 times 4, that answer is going to not be the same thing as the difference of 12 and 3 times 4. Because if you follow the order of operations, you're supposed to multiply 3 by 4 first. So what we have to do is make sure that we put that in parentheses to make the person know, I need you to come up with this answer before you can multiply by 4. And if you did that correctly, you're going to see that number 43 is B. 43 is B. And last but not least, number 44. Which expression represents dividing 6 by n and then subtracting 8? So whenever you work with whenever you work with division or subtraction, you got to be careful because the order totally matters. I always tell students 2 plus 1 is 3, 1 plus 2 is 3. 2 minus 1 is 1, and 1 minus 2 is not 1 anymore. Whenever you add or multiply, the order doesn't matter. The answer is going to stay the same. But whenever you divide or subtract, the order totally matters. So, which expression represents dividing 6 by n? So you are taking 6 and dividing it by n. So 6 divided by n. And then after you, and then subtracting 8. So that's what we have, and we're going to take 8 from it. So you want to make sure that subtracting 8's on this side. Now, order of operation tells us we have to do this first, but it never hurts if you would like to put parentheses. Let's see what our multiple choice option is. Okay, they threw parentheses right there on C. So 6 divided by n, and then subtract 8, which is C. So 44 is C. So, we are through 2 weeks of hanging out at our house and working on some math, and I hope everything's going well. Today, the most people this week worked on their challenge questions, which I appreciate. It's not mandatory, but if you were my child, I'd say, hey, let's work on some math. Let's stay fresh. So hopefully you guys are doing that. Next week I'm going to continue daily to make the challenge questions and probably put them up around 9:30. And then I will also have more questions assigned to you from that packet. So stay positive, stay safe. These next couple of weeks are pretty important to hang out at home, and hopefully you're just not sick of your family. That's what I tell my son every day. Hey, you're not sick of me yet, are you? So far, the answer's been no. My wife's different story. All right. Good luck, and I will be speaking with you all. Bye-bye.